Alright, so second slide, we have a review of the definitions of the three trig functions. So we're supposed to keep in mind that the sine is the opposite over the hypotenuse, and that cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And we have a mnemonic device, or 2 or 3, that we could use. TOA is handy. If we kind of have it written at the top of our paper, even a test paper, even ACT, once they tell you to open up your booklet and start, you can write it down up at the top of the page and refer to it as you need it. Just a quick little mnemonic device to remind us which ones are which we will need for the work that we're doing today. So, if you're ready back there, let's skip right on to the big stuff. So the reason we need the trig functions ultimately is so that we can solve triangles. For now, we're just doing right triangles. There are other trig rules that exist for non-right triangles. We don't typically learn those at this level. So just right triangle trig for now. So I have a triangle, right triangle. I know one side, only one. I need to know another side. Now, Pythagorean theorem would help me if I knew 2 sides already, but I only know one, so Pythagorean theorem is not useful here. I have a couple of special right triangles in my arsenal, things that I've memorized, like a 30, 60, 90, and a 45, 45, 90. I don't have either of those. So Pythagorean theorem won't work. It's not a special case. So Pythagorean theorem won't work, and I don't have a special case. My last option is trigonometry, and this is where the sine, cosine, and tangent are going to come in. So I'm going to remember TOA, and my first line of business is going to be to find a known acute angle. I need an acute angle because trig relates an angle with 2 sides, one angle and 2 sides. So the only acute angle that's currently known is the 33-degree angle. I could find the other one, but that's an extra step, and nobody really wants to do more work, so let's just use that one. And once I locate a known acute angle, I need to see what the relationship is between that angle and the sides that I have to work with. So I definitely have to use the 14. It's the only side I know. Is 14 the opposite of 33, adjacent leg, or the hypotenuse? It's a hypotenuse. So let's label that so we're clear what we got there. 14 is a hypotenuse, which means I'm for sure either going to use sine or cosine in this problem because tangent doesn't involve the hypotenuse. Alright, the side labeled x, I have to use it because I've got to solve for it. Is x the opposite of 33 or is it the adjacent leg? It's opposite. Okay, so the opposite and the hypotenuse are the 2 sides that I have to work with in this problem. Which of the 3 trig functions uses O and H?
So.
Okay, so I've got to go with the so, and S is for sine. I have to use the sine function. So that means I need the sine formula. Now the formula is on the previous page. And things are getting really weird. I'm just not going to worry with that because it just quit. I'll just talk really loud. So sine, actually, the definition gives us a formula. If you flip back to this page, we have sine of an angle equals opposite over hypotenuse. That's a formula. You can stick things in and solve for what's missing. So let's write that down first. Sine of an angle A equals opposite over hypotenuse. I'll just use O over A for now. Well, maybe I'll do OPP over HYP for now because A is an angle in this case, not the adjacent leg. Okay, and then let's put in what we know. So sine of A is the angle, and the angle we used for reference was 33 degrees. So we're going to stick a 33 degrees in for the angle A. So substitution, just substitute into a formula. On the other side, we need something for opposite and something for hypotenuse. The opposite was x. We have that labeled on the picture already. And the hypotenuse was 14. So substitute a 14 in for the hypotenuse. And now we have an equation, which is solvable, with one variable, and you can solve any equation for one variable. Alright, to solve an equation, we need to get x on a side by itself. On the right side, we have x divided by 14. How do you undo divide by 14? Yeah, you're going to multiply. So there's a one-step process to solving this. We're going to multiply each side of the equation by 14. And that way the 14 will cancel out. We'll have just an x left on the right-hand side. And bring down what's left. We have a 14 times sine of 33 degrees equals x. So we've solved for x, except that it's not really a number yet. We really want just one number. How do you suppose we can find what 14 times the sine of 33 is? A calculator. Yeah, that'd be fabulous. Let's use a calculator. So grab your calculators and make sure that you're in degree mode. At the top of the screen there should be a DEG there. If not, then we're going to have to deal with it. Anybody not in degree mode? Okay, so go to your trig key. I'm going to scoot this aside so I can see what I'm typing in. Actually, nope, sorry, you got to put the 14 in first. So we're going to input the expression on the left side of the equation just the way it looks. That's the safest. So 14 times, then we go to the trig key and select sine. Now the calculator forces us to put the angle measure in parentheses. Not a problem. We've already practiced that part. And when you press enter, ta-da, all done. It's about 7.6249 something something something. Let's just round to the nearest tenth. That'll be sufficient. So x is approximately 7.6. Not sure what the units are. Don't know if they're in feet or inches or miles or yards or centimeters because I wasn't told from the beginning. But if I knew the units, it would be the same as I was originally given. Alright, so we now have learned how to solve angles and sides together to find missing parts. Well, at least the first step. We could go further and find the other side of the other angle. So sometimes you get problems where you have to solve for the rest of the pieces and use a little more trig. For now, we just had to find the one side. Alright, do you have questions so far? Alright, so one step to set it up, one step to solve it. Some of the easiest equation solving you do is in the realm of right triangle trig. Alright, let's skip over to the next question. So flip the page, or is it on the same page? I don't know. On the same page. I have to change pages, but you're on the same page. Alright, does this look right? Make sure I got the right page. Alrighty. Okay, so I'm supposed to solve for a missing side because x is a leg of the triangle. I can't use Pythagorean theorem because I don't already know two sides. I know one side length, 5.4, and I know one angle measure, 29 degrees. And if it's easier to see, you can write the 29 degrees inside the angle. Sometimes it just doesn't fit very well. So I can't do Pythagorean theorem because you have to already know two sides to find the third one with Pythagorean theorem. It's not a special case because the only two special cases we have are 30-60-90 and 45-45-90. I don't have either of those. I'm really close. 29 is close to 30, but not quite 30. Let me pause. Alright, so since Pythagorean theorem won't work, and it's not a special case, we have to use trig. And if we have to use trig, we start with an angle. So we know this 29 degree angle right here. What kind of side is x with respect to that angle? It's an opposite, across the triangle from. What kind of side is this 5.4? It is the adjacent leg. Okay, here's how you know. It's attached, so it can't be the opposite. It's attached to the angle that's 29 degrees. And the right angle is right here. You got to look. And across from the right angle is this side over here, this long one. That's your hypotenuse. That's not it. So it's got to be the adjacent leg. All right, which trig function, think about SOHCAHTOA, which one has the O and the A in it? The tangent. Yeah. So I need the tangent. Okay, the tangent formula looks just like the sine formula. You just have a different pair of sides. So the basic setup is the same. Tangent of an angle. So you always put your angle on the left side of the equation with your trig function equals, pay attention back there. It's not helpful if you're distracted. And then on the other side we have opposite over adjacent. And I'm going to, A is an angle, the capital A is an angle. And adjacent, I'm going to use all three letters so I don't get it confused with the angle, because A stands for lots of things. So this is your formula. And we're going to substitute in the angle measure for A. That's the 29-degree angle that we started with. That's our reference angle. And then we said the opposite was the X. And adjacent is the 5.4. Alright, so one step to set it up. Now here's the beautiful thing. If you can go straight to this second step with the numbers substituted in, I'm not going to require you to write the first one down. You don't have to write the one with just the letters and words in it. You can go straight to numbers if you can handle that. If that's too much, write down the formula first. Okay, I got to get X on a side by itself. What will I need to do?
Multiply by 5.4.
Yep, multiply by 5.4. Oh, now that dot looks kind of like a decimal, doesn't it? So maybe I should do times 5.4 with parentheses. And my marker's fizzling out here. Times 5.4 on the other side. Okay, so we got 5.4 times tangent 29 degrees on the left-hand side. And then we have the 5.4's cancel and an X left on the right-hand side. It's exactly the same steps as before. And the rest is a calculator problem. So we're going to just type that puppy in the calculator. So 5.4, you don't have to put that in parentheses. Now that's kind of got a glare. Do the best we can there. Times tangent. You should be pushing buttons, so you're practicing pushing buttons, because on test day I'm not going to tell you which buttons to push. You've got to know how to do that. That's part of your skill set. Tangent 29. Again, we're all in degree mode. If we weren't in degree mode, we could put a degree symbol in to kind of cover for it. But since we're all in degree mode, we're good. Well, and then enter, we get about 2.99. If I round 2.99 to the nearest tenth, that means the first decimal place after the decimal, that 9, has a 9 following it. The 9 is going to make it round up to a 10. So it actually is going to round up to a 3.0 if you do the nearest tenth. Because the 9 rounds up to a 0, and then you carry 1 over to add 1 to the 2 to make a 3. Okay? So that one's kind of a more challenging rounding case. Alright, how we doing? Questions, comments, teardrops? Alright, flip the page. We're going to do 2 more, and then we'll take a stretch break and work on some practice problems on your own. Okay, number the next one. Does this look right? Make sure I got the right slide up. Okay, so it's not a Pythagorean theorem question because I don't already know two sides. It's not a special right triangle because 55 degrees is not one of the special angles that I know about. So it's a trig question. So pick your angle. So 55 degrees is your acute angle. With respect to 55 degrees, what kind of side is X? The opposite, okay? What kind of side is the 33? The adjacent. Alright, so which trig function? TOA, so T is for tangent. Tangent of an angle equals opposite over adjacent. Substitute what you know. Tangent 55 degrees equals, help me finish it. That sounds good. X over 33. Then what? Thank you. Multiply by 33. So times 33 times 33. So 33 times tangent of 55 degrees equals X. And finish it with your calculator. You do it, and I'll catch up with you. So to the nearest tenth, what do we have? 47.1 of some unknown unit. Okay, tell me this is not the easiest step we've done in a long time. It's easy setup if you know which trig functions are which, and if you know the structure of the equation, how this basic structure is. Sine, cosine, tangent of an angle. Angle always goes here. Equals, and the ratio is always your two sides. Okay, things that could go wrong. Occasionally I have students who want to put a side where the angle goes and an angle where the side goes. Sides make the ratio. Angle goes with the trig function. So angle goes on the left, sides go on the right. Do not mix those up. Okay? We have one more question we're going to do today. So the next one's a word problem, right? It's mostly small words. Don't be scared of it. It's just got some words, but they're not bad. Okay. A 12-foot long ladder is leaning against a wall and makes a 77-degree angle with the ground. How high does the ladder reach on the wall? Round to the nearest inch. Inch. Okay. I'll tell you what. I'm going to keep it simple. Let's change it to round to the nearest foot. And let's do it in feet instead of inches, and let's not worry about having to do a conversion right now. I'm really right now just worried about can we do the trig. Okay? All right, what do we need to do first? Draw a picture. Thank you. Good answer. Draw a picture. Okay, there's a wall. Isn't that a lovely wall? Okay. And there's a ladder leaning against the wall. Of course, there's some ground too. So ladder leans. Ground is on the bottom. Most walls stand up best if they're perpendicular to the ground, so we're going to assume there's a right angle between the wall and the ground. The ladder is 12 feet long, so the ladder is going to be this hypotenuse, 12 feet. Label it. The ladder makes a 77-degree angle with the ground. So the ladder is the hypotenuse. The ground is the bottom leg. They meet in the bottom right-hand corner. That's where your 77-degree angle is. Okay, so get everything all labeled. Oh, one more thing to label, and that's what we're looking for. How high does the ladder reach on the wall? So from the ground up to the top of the ladder, I'm assuming is how high up the wall. That's going to be X or P or Q or Y or whatever letter you want it to be. Pick a letter. Alright, it's a trig question because I can't use Pythagorean theorem when I only know one side. It's not a special right triangle. It has to be a trig question. So let's see what kinds of sides we have. With 77 degrees as our reference angle, what kind of side is X? Opposite, okay. And what kind of side is 12? It's the what? Hypotenuse, yes. It's opposite the right angle, so it is the hypotenuse. O and H go with which trig function? Okay, so SOH, S stands for sine. So we're going to use the sine function on this one. Alright, so let's get our basic equation. Sine of an angle equals opposite over hypotenuse. That's our formula. Structure, make sure angle's on the left side, ratio's on the right side. What's A? What's the angle? 77. Okay, so sine of 77 degrees equals, opposite is X, and hypotenuse is 12. Okay? If I have not managed to get 4 questions that have exactly the same work in them, I'm gonna regret that later because I have yet to show you one that has an X in the bottom. I don't know how I managed that, but I did. Okay, multiply by 12, right? Okay, could we save a step here and go ahead and put 12 times sine 77 in the calculator and not have to write it down twice? I think so. Okay, so let's do 12 times sine of 77. And that's about 11.7 to the nearest to the nearest foot means round it to the nearest whole number. So is that going to be 11 feet or is it going to round up to 12 feet? It's going to round up to 12 because we have a 0.6. So it's about 12 feet. Okay, so the ladder and how far it reaches up the wall are nearly the same thing. There's less than a half a foot difference. Okay, how we doing? Piece of cake, right? Okay, I'm going to give you a couple minutes stretch break, and then we're going to dig out the practice problems and work one of the practice ones together with the cosine in it, and I'm going to hush. All right, if y'all can kind of come back to your seats, if you will dig out page 16 of your packet.
I like this whole packet thing. That way not
It's way easier for me too because I don't have to pass out papers every single day.
Yeah.
So it's amazing. Every year I learn something like that I can do better than before. So this will be my last great discovery before I retire, right? The packet system. What's the top 10 one? Whoever takes over from. Let's try it. So on page 16, we've not looked at one with the cosine function. I thought we might want to do one together. Besides, we do one of these together. That's one less you have to do on your own, right? And I also haven't shown you one where the x lands in the denominator, and that creates an extra step in the solving process. And we just need to look at one of those before I turn you loose. So if you look at number 1 on the packet, we'll do it together. So 53 is our reference angle. With respect to 53, what kind of side is 13? It's the adjacent leg. Go ahead and label that ADJ for adjacent. And then x is what kind of side? It's the hypotenuse. Okay, so I'm going to draw it a little bit bigger. I think it's a little hard for me to see here. So x is the hypotenuse, 13 is the adjacent, 53 is our reference angle. So this is the first one we've seen that uses cosine, because cosine is adjacent and hypotenuse together. So formula, cosine of the angle equals adjacent over hypotenuse. Again, if you're savvy enough to go ahead and stick your numbers in as you write that down, that's great. Go right ahead and do it. What's A? What's the angle? 53 degrees. And the adjacent leg is 13, and the hypotenuse is? Okay, so now we're met with a new problem. We have not seen one with x in the denominator before, and that's an issue. Because I need x to be in a numerator to get x equals something. So the extra step involved is to multiply both sides by the x, because whatever's in the denominator is what you have to multiply by. If it's a number, it becomes just a one-step problem. If it's an x, it becomes an extra step. So step 1 is going to be to multiply each side by x, because x has to come out of the denominator at some point. Might as well do it first. Then the x's will cancel. On the left-hand side, we'll have x times cosine 53 degrees, and on the right-hand side, a 13. Now, cosine 53 degrees is some nasty little decimal number, non-repeating, non-terminating decimal. We are not going to get a decimal form for it yet because it's too messy to hang on to. Just leave it as cosine 53. It's just one package that represents some ugly number. There's a multiplication symbol here. X times cosine. How do you undo multiplication? You divide it. So the trick to getting rid of the cosine 53 degrees is to undo the multiplication, and that's to divide by it. So we're going to divide the left side by cosine 53 degrees. Those of you sitting in the back of the room talking, I don't know what you're going to do if you're not paying attention and you don't know what you're doing in a minute. Okay, so divide both sides by cosine 53 degrees, and the cosine 53s will divide out. They'll cancel. On the left-hand side, leave just an x, and then the other side is 13 divided by cosine 53 degrees. The calculator will do that. It's just division instead of multiplication. So grab your calculators. Let's do that division. If you want it to look really pretty like it does on paper, you could do a control divide first and get a fraction template on your screen. You don't have to do that, but it just looks nicer. And then 13 on the top, arrow down, and go get your cosine command in your trig menu. So paste in a cosine and then put a 53 in for your angle. If it looks on the calculator the same as it looks on paper, you can't mess it up unless you set it up on paper wrong. Okay? You don't have to. You can just type in 13 divided by. It works fine. Works fine. So that gives us about 21.6 if we do to the nearest tenth. And we don't know units, so we'll not worry about units now. So if your x is in the denominator, and sometimes it will be, it does add an extra step. Okay, that leaves 9 more problems on that page for you to finish. So you're going to finish numbers 2 through 10, and then you're going to skip past page 17 and go over to page, it's actually a 3-page document. You're going to go over to page 18 and do a couple of word problems. So you're going to do 23. So you'll need a picture for that one. It's similar to what we did with the ladder against the wall problem. Sorry, that's supposed to be a 2. 23, not 33. And 26. Okay, so 11 problems total. 9 with no words and 2 with words. Try not to panic. Just draw a picture first, label your picture, and it's just the same as the no word problems. Tomorrow we'll learn how to find angles, which is the rest of the notes and the rest of that worksheet.